Say hello. Okay, that's it. Hello, guys. Hello.
Hello. We don't worry.
Hello, Eric. Hello, Ryan.
I'm a rabbit.
Okay, enough.
Excuse me.
Hello.
Yeah.
Sit down. Sit down.
Sorry, babe.
Hello, so today,
We're talking about mathematics, not coding today.
yeah, we're going to talk about these methods.
Yeah?
Sit down, please. Maths.
Yeah.
Sit down, please. Math induction. Yeah.
Math induction.
Induction. So, do you know what's induction mean?
Instruction.
No, not instruction. Induction. Okay, you don't understand. That's fine. Okay, so this is a powerful tool to prove that prove a formula if it's correct or not, right? So for example, like if I want to know, look, if f is the function, yeah, fn is the function of the sum for the first n natural numbers. You know what's natural numbers?
Natural numbers.
2, 3, 4. These are natural numbers, integers. Yes?
No.
Sit down, please.
In a range.
Natural
What's these?
number. Yeah, natural numbers.
That looks like waiter.
Natural numbers. So
Natural.
everything is non-negative, right? No,
Ouch.
not
Yeah.
actually it is positive numbers. Yes. So positive
Wow, you love that.
positive integers.
I
Yes.
want to see the camera. Yeah, but I can't.
Positive integers. Yeah. Please be quiet.
Positivity.
Positive integers. Okay. So can you tell me the sum of the first four integers? What's the sum of the first four integers?
1, 2, 3, 4.
Yeah,
5,
yeah.
6, 7, 8, 9.
F4.
See? Big brain. That.
F4 equals what?
F4 equals 1, 3, 4.
What's the sum of these?
10.
And F5?
50.
Keep quiet. You're going to be on YouTube, okay? Don't be so naughty, okay?
You're being funny. You're making fun.
So, if we know this proposition, do you know this word? Propositions.
Place.
Proposition is like you propose something, yeah? It's the noun for the propose, yeah? Proposition is
Is it add?
yeah, if I tell you, okay, can you prove to me that the sum of the first few natural number, positive integer, is n times n plus 1
Plus
divided by 2? Yeah, this is the
What
formula.
does that mean?
Look, what did you say? F4 equals what?
10.
10. F5 equals,
15.
okay, 4 times
Actually,
4 plus
21.
1 divided by 2 equals how many?
4 times 4. 4 times 5 equals 20.
And divided by 2?
10.
Okay. And how about 5 times 5 plus 1 divided by 2?
So 5 times 6 is
15
divided by 2. 15!
So do you see? This is the
Oh
formula.
yeah, oh yeah,
So if I tell you the first F100 equals what?
50.
Yes, how do you know?
Easy, babe.
Look, the formula. What did I just tell you? Formula equals 100 times 100 plus 1 divided by 2, right? Yeah. This is 50-50, okay? Okay? Yes?
Yeah.
Okay, so this is the formula for the sum of the first.
No, 50,
And-
50, 5,050.
It's the
Yeah,
same.
yeah, it's that
For the
very
first
quick
sum of the
mathematics.
sum of the first few positive integers, okay?
Yeah.
Okay, so now,
We don't right there.
so going back to the topics, math induction. Okay, so if I told you that Ryan, please. If I told you that Fn is n times n plus 1 divided by 2, yeah? Okay? So we need to do 2 steps to prove that this is correct. How do we do it? So first of all, when n is 1, so what's the answer?
1.
Yes, right?
See? Big brain.
Can you calm down? And 1 times 2, 2 divided by 2, 1, right?
Yeah.
Okay. So when n is 1, the base case, we call it base case because n is the minimum is n is 1, then the answer is 1, right? Okay, so now if look, Ryan, are you okay? Ryan, be good boy, okay? You're on TV, okay? Now look, if n is if we talk if we assume that n is k, right? Fk
What
equal
does K?
just any number, okay? K equals k.
Number, did you say?
K equals k
Number,
plus
did
1
you say?
divided by 2,
Did
okay?
you say what did you say?
Evan?
K.
Okay, so if Fk equals k plus, yeah?
If K is the same as N,
Yeah. Now,
then why didn't you do N?
what's Fk plus 1? What's the answer of k plus 1? Fk plus, is it equals to Fk plus k plus 1, right? Am I right?
Yeah.
Because now I got the sum of the first k numbers. I just need to add one more, right? Yes? Yes?
You just add 1, not K add 1.
No, k add 1. Because this is, look, F4, F5,
Okay,
is it equals to F4 plus 5, right? Am I right?
Yeah, but it hasn't got add at the end.
F5,
F5?
yeah,
So
F5.
it's supposed to be add K.
I know.
Add 1.
No, k plus 1. Look, k is 4, then k plus 1 is 5. That's what I meant. Do you get it?
Yeah, but FK add K add 1, F4 add 5.
Yeah.
Much shorter. Why is it much shorter?
What do you mean much shorter? So this is
F5
the general
is
case.
shorter than FK. Why?
No, I'm just saying this is an example. This is a general case. Okay? General case.
Yeah.
General case, yes?
Yeah.
Okay. So now Fk equals Fk plus 1 equals Fk plus k plus 1, right? Okay, so how do we do this? So going back to this. No? No?
Define.
So
Define maths.
so look, let me just write it. Look, okay? Fk plus 1 equals Fk plus k plus 1, right? This is the k plus 1 portion.
Yes.
So
I heard that.
this is k plus 1 divided by 2, right? Yeah? Yeah, we know that, right? So this is k plus 1. What can we do about it? We can do it is 2 k plus 1 is the same thing, yeah? Am I right?
Yeah.
Okay. So now,
Yeah.
if we merge these two, how can we merge these two?
Emergency.
Two, look.
Emergency.
If they're both the over 2s, right? Also like 2 here. So k plus 1
One
plus
plus
2
one.
k plus 1, right? Am I right? Yes? Look, there's a common here, k plus 1, right? So it equals 2
K add 2.
k plus 1 and then k add 2. Yes, we're done, okay?
Yeah, baby.
Okay, so look,
Yeah, baby.
look, wait.
Yeah.
So what's next? Look, magic, this is magic, look.
Why is it?
Look, this is magic, look. So this k plus 2 equals k plus 1 plus 1, right?
Plus 1.
Yes?
Plus
Yes.
1 add 1. Why? Why is that 1?
K plus 2 is equal to k plus 1 plus 1, yeah? It's the
Yeah.
same. Okay, look,
But that's the longest way.
I know, look, k plus 1, k plus 1, k plus 1. So if I if I say t equals k plus 1, so I can do ft equals t times t plus 1 divided by 2. You see? Do you see this? It's the same.
I can see it.
Okay, do you see? So
What do you get?
so what does it mean?
Jingle bell.
What does it mean? Eric, what does it mean? We prove that the base case when k equals 1, the proposition, this formula, yeah? Yeah, is correct, right? We assume the fk is correct. And then when we add one more item, yeah?
It always be the same.
Yes, the formula is the same. Look, so we prove that this formula is correct. This is called mass induction.
It always be the same.
Do you get it?
Yeah. I'm buying.
Do you see it?
Jingle bells.
So let's mathematics induction. Here is a more difficult one, okay?
More difficult.
Sum of squares, like that. If I saw fk equals 1 square plus 2 square plus 3 square plus k square. Okay, I tell you that this sum equals n plus 1 to n plus 1. Yeah, this is the formula.
That means k is bigger than 3.
Now look, can we say the base cases when k is 1? When k is 1, what's the sum? It's 1, right?
Yeah.
The first item. So let's see if it's 1, okay? So n is 1, k is 1. So 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6. Is it 1? 1 times 2,
Plus 3.
2 times 1, 2 plus 1, 3, right? 1 times 2 times 3, 6 divided by 6, 1.
Why is it divided by 6?
This is the formula, preposition. You know, I just told you it's that, and I want you to prove that it's correct. So we prove. We first of all we prove.
You're better than me.
So we So we prove that the when k is 1, the base case is correct, right?
Yes.
Okay. Now, if you're not sure, let when k is 2, what's the answer?
K is 2. It'll be all the same. 1.
1 square plus 2 square.
1 square plus 2 square.
That's 5.
Yeah.
5. Okay, look. Put a 2 here. 2 times 2 plus 1 times 2 times 2 plus 1 divided by 6. 2 times 3, 6. Okay? So this is gone, yeah? 2 times 2 plus 1. 5, yeah?
Yes.
So look, k equals 2 is also correct, okay? So now let's prove it. So we just prove when k is 1, the base case is correct. Now we need to assume when fk is correct, and then when add one more, so one more item, what's that? It's k plus 1, right? Square, right? Yeah? Am I right? Yes?
Yes.
So look, now this fk. Okay, let me just write it there, okay? So easier.
Mud on your feet.
fk plus k plus 1 square equals 6 and 6k, k plus 1, 2k plus 1, plus this item, I also put it 6, and then now becomes 6k plus 1 square, right? Yes? Am I right? So why I do this? Because they are both over 6, so I can merge these two items. So 6, and then now I have k plus 1 here, so I put a k plus 1. Okay, now this item will be k times 2k plus 1, right? Plus, is it plus? I take a plus. Plus what? 6k plus 1, okay? Alright?
Why don't you do a square?
Which one?
A
Where?
square.
Where is square?
There's the 2.
This one?
Yeah, why don't you do
Because I take the k plus 1 out. They both have this k plus 1. Yeah? This is called, look, if AB plus AC, what? You can convert it as AB plus C, yeah? Alright?
2A add B.
Look, because they have both A, I can take it out, and then these two just added it. Yeah? Add it together, am I right? For example, 2 times 5 plus 2 times 3 equals 2 times 5 plus 3, right? That's 10, that's 16. 2 times 8, 16. You see? Yeah? Do you get it?
Yeah.
Okay. So now, look. Sorry. So look, this. So can we prove that it's correct? Look, this is this is a bit complicated, yeah? This is 2k squared plus k, right? Plus 6k plus 6, okay? So look, so this is 2k squared plus 7k plus 6, right? So this thing is equals to, it should be equals to what? To k plus 2 times 2k plus 1 plus 1. Okay, so it should be this way. So we prove we can do this. 2k plus 1. Look, it's k plus 2, 2k plus 2 plus 1, 3. Okay, so it's the same. Why is it the same? So here, look. Yeah, look. 2k squared plus 3k plus 4k is 7k, yeah? 7k. Plus
1
plus 2
3
and 3 plus 6. So look, these two items are equal. So we prove that when k plus 1, because this is k plus 1, we can make it a t. Then it will be the same as t plus 1, 2t plus 1. Yeah? You see?
That's K.
Yeah, I know. So yeah, k. So this is called mass induction. So to sum up, we need to do two steps. First of all, prove base case. Okay, base case. Remember, when this sum, yeah, this sum of first n integers is when n is 1, the sum is 1. 2, which is called induction step. So what does it mean? So if we assume when n equals k, the fn function, yeah, fk function, and then we need to add one more item, fk plus k plus 1, right? This is when fk plus 1. We can do this, and then we need to prove this formula also can be represented using this original formula. Then we can prove this formula stand. Do you get it?
Yeah.
Okay?
Yeah.
Any questions so far?
No. Bye-bye. Bye-bye. Oh, baby, Christmas toy. Whoa, baby.
Okay, hurry up.